Hello, my name is Gijs Wolterink. I'm at the University of Twente, and my poster is about a 3D printed calorimetric flow sensor. So 3D printed sensors are of interest because their customizability and their ability to integrate in other 3D printed structures. So this poster shows a proof of principle calorimetric flow sensor that's printed in one go. So a calorimetric flow sensor works following the following principle. So here we have a tube in which fluid flows through, within the center a heater, and on both sides are temperature sensors. So what happens if the flow rate in this tube increases, we see that the temperature profile changes, and therefore we can use the temperature sensors to measure the flow rate in the tube. Our 3D printed flow sensor is printed out of thermoplastic polyurethane, or TPU, and the sensors of our calorimetric flow sensor and the heater are also printed out of a TPU, but to give it conductive properties, this TPU is blended with carbon particles. So to get to know more about this conductive TPU, about its thermal properties, we place it in the oven, and what we see is that if we increase the temperature, we also see that the resistance increases. What we see here at around 110 degrees is that the resistance drops a little bit. This might be caused due to the formation of conductive networks. Furthermore, we see that if we decrease the temperature again, that the resistance will decrease, but we see that this happens with some hysteresis. And this might be caused due to annealing of the material. And that's also supported by the figure shown here, where we see that after each heating cycle, we see that the resistance decreases. So this figure shows the simulated and the measured output of our calorimetric flow sensor, and we see that it's almost linear to about 3 millimeters per minute. So at the moment the output of a sensor is quite small, till about 3 millimeters per minute, but the sensor is 3D printed, and a nice thing about 3D printing is that we can really easily change the dimensions and the properties of the sensor. So in conclusion, we showed the first fully FDM 3D printed calorimetric flow sensor. And we also showed that the conductive TPU that we used is sufficient sensitive enough to temperature changes to use for thermal sensing applications. So if you have any questions, please feel free to contact me.